What is India's big step in fighter safety tech? How it has helped India to enter an elite defense club. What are the consequences of it and how it changes the game of Atmanirbhar Bharat. 800 kilometers per hour, milliseconds to react, and one mission to save the pilot. And in this very condition, DRDO has successfully tested high-speed flight escape system. Hello everyone, welcome to Vajiram and Ravi's Flash News. My name is Shubhangi Singh and today we are going to talk about this indigenous feat by DRDO, why it matters, what will it bring on the table and how it places India in an elite defense club as well. So let us begin with understanding what exactly has happened. So if we talk about DRDO has conducted a high-speed test of the indigenous fighter aircraft escape system. So that means if in extreme situation in a fighter aircraft there is a situation where the pilot needs to be saved in the fraction of seconds, this escape system which has been indigenously developed in our country, that has been tested and it has come out well. Now this was conducted at the rail track rocket sled that is present in Chandigarh and the testing speed here was 800 kilometers per hour. Furthermore, it validated other parts of the escape system, that is canopy severance, ejection sequencing, air crew recovery. I'll be talking about these in detail. Why this is important for all of us is because this marks a major progression and breakthrough, especially when we are talking about pilot safety ecosystem. In a time where during a Dubai air show, our pilot could not make it, such pilot safety systems mark the progression, mark the fact that it is the focus of our forces, government on saving lives and also the defense self-reliance that we can do this on our own as well. Now when we are talking about this whole feat, the achievement that we are discussing, it also becomes important to understand what was the reason that this test was conducted. So if we talk about the modern fighter jets and their working, we have to understand that they operate at extremely high speed and also G-forces. And in this particular context, pilot ejection or their escape system has to work or has to facilitate the moving away of pilot from that particular fighter jet in less than 0.2 to 0.4 seconds. And for this whole system, India has heavily relied on imported escape system, mainly the Martin Baker from United Kingdom. Furthermore, if we talk about the future Indian fighters, which includes LCA Mk2, AMCA, all of these need fully indigenous safety systems. And for this very context, this test was very much needed and the success of it is going to facilitate the upcoming line of fighter jets as well. So the whole idea of this test was part of the mission that DRDO has taken up to indigenize the critical life-saving airspace technologies as well. Now, when we want to understand this in better detail, in more clarity, it becomes important that we also look into that how exactly a safe system or an escape system works. So, when we talk about an escape system, it has many parts starting with canopy severance. That means the canopy which is present in the fighter jet, that needs to go away. So this is where the explosive cords cut away this particular canopy. Then we get to see the rocket ejection seat. That means the pilot's seat is propelled out of the place. Pilot is present here and it is propelled out of this place. Then we get to see the drag chutes which stabilizes the spin of the whole parachute and the pilot, and we also have sensors which are present to manage the altitude and also the speed which is present. And the final step is where the main parachute opens for the descent of the pilot. Now, if you want to understand this whole escape system and its functioning, it needs to be tested in real time, and that is why in this particular testing, we got to see that That's why in this particular testing, we got to see this in a test rig which was made, and it mimicked the cockpit which was moving at the speed of 800 km per hour. So basically we had a cockpit which was mounted on RTRS, which is rocket propelled sled, which was working on the rail track. So we were getting the speed on this RTRS of 800 km per hour. So acceleration happened and it simulated the real in-flight emergency conditions, and that is where we got the validation. As I just showed you the whole escape process, in this we got the validation of canopy brake, we got the validation of seat ejection, and also the parachute deployment, which you can clearly see in the videos that have been surfacing. Now, many of you might question that why it has been done in a simulated condition, why not in the real condition? In this particular context, it becomes very important that you understand the importance of rocket sled testing, because it simulated jet-like speed, but at the same time, the risk which was involved with being airborne, that was reduced. So it had a controlled, repeatable and also highly instrumented experience, and the test was under extreme aerodynamic loads as well. So this is where it becomes important to do the experiment also, but reduce the risk while keeping every dynamic in the mind. And when talking about fighter jets, the aerodynamic loads are one of the most important ones. Now, even this rocket sled testing that has been done by very limited nations across the globe. Now, I hope I have built in the system, you have a clarity of the system that has been made, the system that has been tested. I hope this has brought clarity into the fact that how the system works, what has been done. Now we will be moving on to talk about that why this milestone matters. Starting with the first one, the strategic significance. This particular system test places India in a position where we can talk about full self-reliance, especially in terms of pilot safety systems. It will reduce our dependence, especially on UK, Russia and Israel, on the nations we depend for escape technology. And this is very important during sanctions or wartime supply disruptions, just like we have seen recently in context of Russia. Other than that, if you look at other dimensions, we also have a operational significance here that is very much associated with the enhancement of survivability of Indian Air Force pilots, because these are one of the most valuable assets for our country, and ensuring their safety across the full flight envelope becomes very important. So this particular mission also adds to that, where there is safety provision for these pilots even at high speed and low altitude missions. Furthermore, this also has an economic and industrial aspect to it, where when we are talking about indigenous capability, we are enhancing it, be it in explosive system, be it in sensors and composites, and this facilitates whole of the Atmanirbhar Bharat mission, where the defense manufacturing gets a boost, the exports related to defense manufacturing gets a boost as well. Now that we have understood the significance, let us move and discuss that how this places India in an elite defense club. So when we talk about this very technology, as of now only numbered nations have their own made escape seat as well as high speed testing capability, which includes United States, which includes Russia. It includes United Kingdom as well, and as you know, we have been highly dependent on United Kingdom for Martin Baker, which is the world's largest supplier. It exports to 90 plus countries and they have a proprietary testing track as well. But other than that, we have few other nations such as France, which have escape system for the Rafale fighter jets and the Mirage series as well, and then two other including China and Sweden. And the seventh entry to this club is going to be India. So India is joining this elite club which has their indigenous escape systems and testing trials which have been done in the places. Now we will be moving on to discuss that what are the implications of this particular testing, especially for India's fighter aircraft program. So the immediate impact that you will get to see that there will be proper integration of this escape system with LCA Tejas Mk2, which becomes very important in the recent light of events that have happened. This will bring in safety enhancement for them. There will be potential upgrades for Su-30 MKI as well. But for the long-term impact, that is where we will get the full-fledged improvement and usability of this, where it will be used for AMCA, which is our 5th gen fighter jet, Indian fighter jet most importantly. It will be essential for the naval fighters, especially TEDBF, and it will increase India's competitiveness in aircraft exports, especially from the context of Tejas, which is in pipeline for Malaysia, Egypt and Philippines as well. On this note, it becomes also important to acknowledge that it will have a direct impact on the research and development ecosystem as well, where it is going to strengthen the collaboration not just for DRDO but for Hindustan Aeronautics Limited as well as ADA, and it opens better pathways for indigenous G-suits, survival gear and pilot safety tech as well. But all of this is not limited to the glory that has come with it or the achievement that has come with it. The important thing here is also the challenges that lie in front of us. For example, the technical challenges. For example, we don't have to just test it at one speed, but it needs to be tested at multiple speeds and also especially at subsonic and transonic speed, where subsonic speed is usually less than the speed of sound and transonic is somewhere in the range of 0.8 Mach to 1.2 Mach. That means near to the speed of sound. The simulations need to be also tested, especially in different altitude and temperature variations as well, and the reliability needs to come across all sorts of operations, be it night operations, sea level operations and high altitude region as well. Then also comes in the certification challenges, because it is important that this flight escape system also meets or exceeds the certification levels, be it of NATO or Russian standards, and there will be a need for human rating and regular safety audits as well. Apart from that, production challenges will be also upcoming, because if we talk about serial production of explosive cords, sensors and composite seats are limited in our country as of now, and that will be required if we want this escape system to be indigenously installed as well and to be part of our line of fighter jets. Furthermore, another challenge would be maintaining uniform supply and quality, which has been a long problem that we have seen. As of now, the way forward would be multiple test cycles and also the full system qualification and integration with the prototype aircraft test beds that are coming in front of us. Now on this note, I will be concluding. If you have any thoughts on this, you can put it down in the comment section. That was all from my side. Thank you so much.